Blocked by CORS policy. If you build for the web, you have seen that red line in the browser console. And the first thing almost everyone believes about it is wrong. That message does not mean your request failed. It does not mean the server rejected you. The request went out. The server answered. The browser is simply refusing to hand that answer to your JavaScript. So let me show you the exact attack that rule exists to stop, and then the one line of server code that opens it up safely.
Start with the attack, not the rule. Picture two tabs open in your browser. In the first one, you are logged into your bank. In the second one, you open some random site you have never heard of. That random site runs a little bit of JavaScript, and it asks your bank for your balance. Here is the part people miss. Your browser automatically attaches your bank cookies to that request because the request is going to your bank, so it arrives fully logged in, as you. Without a rule, that random site just read your balance.
That rule is called the same origin policy, and it is the oldest safety rule in the browser. An origin is three things glued together: the protocol, the hostname, and the port number. If all three match, a page is allowed to read the answer. Change any one of them, and it is a different origin. Plain HTTP instead of the secure one, a different hostname, a different port. Different origin means the browser will not let your page read the response. Blocked is the starting position, not the punishment.
Now here is the code that gets you the error. Your front end runs on one address. Your interface to the server, your API, runs on another. You call fetch, you wait for the response, and it never arrives. What you see in the console is a network error, plus that CORS line. And this is where the story goes wrong, because that looks exactly like a request that never got through. It looks like the server said no. Neither of those is what happened.
Here is what actually happened. Your request left the browser. It traveled across the network. The server ran your handler. It may well have written to the database. It sent a real response back with a real status code. And then, at the very last step, the browser looked at that response, did not find permission for your page, and threw the body away before your code could touch it. Nothing was stopped at the door. Something was withheld at the end.
So how does a server give permission? With one header in one exchange. When your page makes a cross-origin call, the browser adds a header called origin and fills in your page's address. It does that itself. You cannot fake it from JavaScript. The server sees that header and decides. If it wants to allow you, it puts a header on the response called access control allow origin, naming your page. The browser compares the two. Match, and your JavaScript gets the data. Missing or different, and the browser keeps it.
Which means the fix lives on the server, not in your front end. In Python, with the FastAPI framework, it is a middleware, a small layer that touches every response on the way out. You give it the list of origins you trust, and it adds that allow header for you. Notice what you are actually writing: a real list with real addresses in it, not a wildcard, not a switch that says allow everything. You are naming the pages you are willing to be read by. That is the whole configuration.
And it is the same idea everywhere else. In Node, with Express, you install the CORS package and hand it the same list. In nginx, if your API sits behind it, you add the header directly in the config file. 3 different stacks, 3 different spellings, one identical idea. The server states, on the response, which pages are allowed to read it. Nothing about this lives in the browser, and nothing about it lives in your client code.
There is one more moving part, and it surprises people the first time they see it in the Network tab. For plain, ordinary requests, the browser just sends it and checks the answer afterwards. But if your request is anything unusual, the browser will not send it blind. A put, a delete, a custom header, a JSON content type. For those, it sends a small question first using the options method that asks, "I would like to send this. May I?" Only if the server answers yes does the real request go. So one call in your code can be 2 calls on the wire.
Now, the trap that turns a fix into a hole. A star means allow every website on the internet to read this. On a public read-only API, that is genuinely fine. On anything that uses cookies, it is not. And the browser actually forbids that combination. If you switch credentials on, so cookies travel, the star is rejected outright. You must name real origins. So the safe shape is this: a real list and credentials on only when you truly need the cookie to go along. Name who you trust, then decide whether they get to be logged in.
Which finally explains the sentence every backend developer has said out loud, but it works in curl. Of course it does. CORS is not a rule your server enforces. It is a rule your browser enforces. And curl is not a browser. There is no logged-in person sitting behind it. There is no cookie jar it will attach on your behalf. There is no untrusted JavaScript it is trying to protect you from. So the policy simply does not apply. Curl working proves your API is up. It proves nothing at all about CORS. So let us count what this really costs you. 3 parts make an origin: protocol, host, and port. 1 response header carries the whole permission. And 0 of the real fixes belong in your front-end code. That last number is the one that matters. Disabling web security in your own browser or installing an extension that strips the rule fixes nothing. It only lies to you on your machine, while every actual visitor still gets blocked.
So, the whole thing, in 4 lines. The error does not mean rejected. It means withheld, and your handler already ran. The browser sends origin. The server answers with access-controlled allow origin. Unusual requests get an options preflight first, so the server has to answer that one too. And a star cannot be combined with cookies, so name the origins you trust. Fix the server, never your security.
If that finally made CORS click, hit like and subscribe. One concept all the way down to the code, every time. There is a short version of this one linked in the description if you ever need the fast refresher. See you in the next one.